start matching up diameter of the bolt, diameter of your tap. And then I'll lay the two together just like laying a pair of combs together, tooth to tooth. The other thing you can use is we have a thread gauge. It has little teeth on it. It looks like a mustache brush. All right, or a mustache comb. All those little numbers are threads per inch. Pass that around. And you can take that and lay it in the bolt. You'd still have to measure your diameter though. So that's where a dial caliper comes in. So you can use one of those. Typically they're, I don't have one at home. And then I'll just use a tap to check them out, measure them that way. We're going to be looking at this mill and at that one. Many of you have already been milling your base, working on the feet. We've got the pattern laid out. We've got some holes started. And I'm using a nice chuck here for my drilling. I'm moving from hole to hole with my wiggler. Turn it off so you can hear me. Normally I'd leave that running just to make sure it stays true. Now I was doing this a little bit earlier and it didn't line up perfectly. For some reason my pattern was not dead on, for example, my x-axis. If that's the case, should I shift my hole according to the x-axis, or should I shift my y-axis to match it up?
Y-axis.
Which should I shift? The y-axis?
Yes.
Okay. I agree with you. Now tell me why.
The fixture might not be true.
We can mill our feet in this horizontal plane with a fixture just about anywhere. And we can even lay out our square with our fixture just about anywhere. But if the fixture is not true and we just say, well, I'm just going to shift it because my X tells me I'm off a little bit. Now you're actually putting your hole in the wrong spot. So, yeah, get her located, line her up. And we're drilling. The drawings call for a 64th drill, 1/64th under, the 11/32 ring. You can go down to a 5/16, which is the next one down. That would work as well. People can't see. I love it. Helps to lock your table so you don't make that mistake. I like pecking in and out. There's your chips. Gives your drill a little bit of time to cool off. You don't need the oil. With machining, you can go with coolant or not. We're talking coolant, 3 jobs. 3 jobs this coolant has. Lubricates, cools, and it blows our chips away. Industry does it all the time. They're also working on the longest life of their tool. reasonably clean, and time isn't near the issue. Okay, we've got our hole. Before we move anything, we go right to the ream. Ream is a slow speed, fast feed. So that's a little off on you.
Yeah, let's stay back where you
Pay attention here. Okay. Better. What works for me with this, I was turning at about 1100 RPM. I go to low range. Now I'm turning to 130. That's all I need to do. I don't even need to change my variable here. And change my switch. That's the kind of speed we have now. This we use a little bit of oil on. Ream takes off very little, but makes a perfectly round hole for us. Down, out, down. Okay? That's all we need to do. Take that out, put the wiggler in, find the next hole, do that one. Okay. We have our 4 holes. Our next step is to go onto our fixture for milling the ends. Let's take